We talk about application of partial derivative in business and economics. Here's the formula. It represents the partial derivative of function k with respect to the variable x. Delta k over delta x. This is another way to express the partial derivative. Delta is the symbol for partial differential operator, and delta x indicates differentiation with respect to the variable x. And also key x, it signifies the rate of change of the function k when variable x changes slightly while variable y is held constant. Marginal analysis refers to the practice of using a derivative to estimate the change in the value of function resulting from a 1 unit increase in one of its variables. So absolutely, marginal analysis is a powerful tool used in economics and other fields to make informed decisions. Derivatives measure the rate of change of function. They provide the slope of curve at a specific point. The example like marginal profit is equals to derivative of profit function. The real-world application in business, this derivative also can optimal the output levels like production decision, determining optimal production level to maximize the profit, and pricing strategies. It's setting price that balance demand and revenue, hiring decision, deciding how many employees to hire and minimize costs and maximize the output. While in the real-world application in economics, they can understanding about the consumer behavior or understanding price elasticity and also analyzing supplies and demand interaction. In other words, it can test the market equilibrium like analyzing how supply and demand interact to determine market price.
Speaking of the market, let's talk about the price of things. Did you know that commodities have two categories, which are complementary and substitute? What are those, Shifa?
Substitute. Substitute is if a price is too expensive, the other one can be served for the expensive because it's cheaper. Example for substitute is like bread and rice. The demand for each increase with respect to the price of the other. Partial d1 divided by partial p2 is more than 0 and partial d2 divided by partial p1 is more than 0. Complementary. While complementary, if one price goes down, the demand for both these goes down too. Example for complementary is like flour and bread. The demand for each decreases with respect to the price of the other. Partial d1 divided by partial p2 is less than 0 and partial d2 divided by partial p1 is less than 0. Optimizing functions of two variables. Unconstrained optimization. Optimizing function of two variables is to find the highest point and the lowest point of the variables in the graph.
Let's take a look, for example, of marginal analysis. Say, imagine a factory where the weekly output QXY is given by this. Here, X is the number of skilled workers and Y is the number of unskilled workers. Currently, there are 30 skilled workers and 60 unskilled workers. We want to estimate the change in output if we add one more unskilled worker. First, we find the partial derivative with respect to y, which is 500 plus x squared minus 2y. After that, substitute both x and y. So then, to substitute this, we get 500 plus 30 squared minus 2 times 60 equals 1280. So, the estimated change in output is 1280 times 1, which is 1280 units. Let's take a look at optimization example. A company makes two products, G1 and G2, sold at $70 and $50 each. The total cost is x squared plus xy plus y squared, where x and y are the amounts of G1 and G2 produced. We want to maximize profit, which means we need to find the TR equation or total revenue equation, because profit is equal to total revenue minus total cost. The equation for total revenue is 70 times x plus 50 times y. Input that into the maximized profit equation, which is TR minus TC. That means equation TR minus equation TC. To find the best production level, we set partial derivatives to 0. As we've seen below, both are derivatives in respect to x and y, each separated. Solving this, we get x equal 30 and y equal 10. As for the maximum profit is equal to 70 times 30 plus 50 times 10 minus 30 squared minus 30 times 10 minus 10 squared is equal to 1,300. And that's the end result. The maximum profit is 1,300.